Oh, is he?
Yeah. Yeah. I don't really work on multitasking. I'm there.
Okay. Good, because that was the big concern we were talking about. We're looking for a note taker.
I just saw that he was looking at,
Yeah, okay.
yeah, no, I'm looking at something.
So we need to get someone to take minutes for us. If you've not been out yet before, or you're fairly newcomer to IETF, it's a really good way to stay engaged in conversation, not distracted with email and all stuff like that. So we cannot continue that everything. And first, you volunteering to take minutes?
That's a yes in German.
Actually, I've stuck roles in this role quite a bit. Stig and I have reversed roles to take care of each other's requirements in class. I'm not going to sit down and do it well. I did local beers. I walked around and do stuff. I didn't have that. So anyway, note taker. Note taker. What's that percent? You know, like smell that and really do that. Do you take minutes before? No? Anyone else can take minutes?
We can't fly this plane until we, this plane will not take off until we have a minute taker. Coffee meeting.
Come on. Mike?
No, I have audio processing delays and I can't type fast enough. My delay, I tried. And it was a disaster last.
Yeah.
But I'll volunteer Greg.
Yeah,
I think that's good. Got you, Mike? Thank you, appreciate it. I will reciprocate eventually. But that monster or that one? No, I wouldn't. You're the Dracula, man. No idea. All right, let the ceremonies begin.
Yes, JavaScript. That's the easy one. All right.
Oh, excellent, thank you.
All right. Are we expecting any more or should we?
We probably are, but let's shut the door just to keep the noise out. Can you grab that for us?
We can wait another minute because we can talk about. No, we've got plenty of time this time. Yeah, it's a small room. We walked by it a few times. We'll give them time.
Nice elevator. I thought about it.
Yeah, we have two remote presenters. We've got about 90 minutes of agenda in a two-hour time frame, so we can wait a moment. If you guys want to make some recommendations as to restaurants you've been to that are excellent or bars.
That, you know, I mapped that and it showed it was like 4 times standard load. It was like way busy, so I walked the road, but it was good.
It's big.
I would,
It has 2 bars and lots of.
Okay.
It's close. Right.
Well, if we do this post session here at lunch, I like that idea.
is that the one? It's the bar. It's the brewery that's kind of a block away. Because I went to one of those. Okay.
So I hit one.
No, I just went for lunch to some place, and it was a brewery, but it was not a very wide selection.
Well, I went to Brewtopia. Yeah, it was okay. It was okay. Just typical bar food, very local crowd, which I thought was interesting. I thought it was a good one, traveling in downtown.
It was 3 brasses.
Oh, yeah, that's cheap.
Ah, okay. Yes,
Yeah, and then also-
they had some interesting
Beer Market's
food.
right around the corner from it's like the Brewtopia.
If you're a lager drinker, it was not a great. Yep,
Thank you.
thanks.
You can come stay.
She wasn't here to tell us that we're supposed to get started for real.
Also, Jeff waited until we had a note taker, so we can get started now.
Jeffrey, thank you. We appreciate you being the note taker. As always, you're the best note taker we've ever had.
Best, Jeffrey. No, we got one. Mike McBride is volunteer.
Okay.
And I want to make that publicly known that we really appreciate you in every way. Yeah.
All right.
Predisposition to sounding sincere.
All right. You think we should start now?
Start out.
Jeffrey's here, so we can start. All right. Welcome to PIM. No. Sorry. Welcome to Mboned. This is Mboned. Here is the note well. Please note it well. Folks on the Meet Echo, we see Dale, Jake, Kerry, Lorenzo, Lucas, and Natalie. Can you guys hear us? Yeah, this is the widest audience we've ever had remotely, at least for a while. That is a yes. Okay. From those people? Okay. Great. Cool. All right. Here's our agenda. We're going to switch things around slightly. You want to full screen that?
Yeah, I was going to try to find the document.
Okay.
That's as full as we get us.
All right. Oh, there we go.
Oh, that's fit to me.
Yes. Okay. Cool.
But now I can go back to my
We'll get there. This is the agenda. A fairly full agenda. It's a good thing we got our own room now because we're gonna use it. Our own session. Oh yeah, blue sheets. That's a good point. Yeah. These are the blue sheets. Be sure to sign them. What, the front page? Yeah, okay. All right, please sign the blue sheets. Hitoshi's here to talk about M-Trace, and he has some late-breaking news that we're excited to hear about, I'm sure. Mike has a couple presentations on update and new beer entropy. Jake's going to be presenting remotely. We're probably going to move Natalie up right before Jake to present remotely, and then Torlis has a couple presentations. So let's see, next slide. All right. So of our active working group documents, we have M-Trace, which has been stuck for a while with security issues at IESG. And Hitoshi's going to provide us an update. Hopefully he has figured out a way to unstick those. We have the deploy draft, the data center deploy draft. Mike's going to provide an update on that. Mike, do you want to tell us what's going on the MCAS problem statement draft?
We haven't. Mike McBride, we didn't do any updates since the last IETF on that
IEEE 802 multicast problem statement. So we didn't ask for a slot this time. So I'm not exactly sure. Probably what we'll do is we'll probably do another update before Bangkok, present it there. I think we'll probably be pretty close at that time to ask for our working group last call.
Cool. All right. And then the Yang models draft was adopted successfully since London. Sandy, is Sandy here? No Sandy. That's ready to be, reissued as a working group document. So after a while, took a while, but now we're a working group document, so we're ready for that. Other drafts, there's the deprecate draft, which is actually in a current ongoing call for adoption. We would really appreciate folks replying to that adoption call, either yay or nay, if you think it should or should not be adopted. Torlis is going to provide an update on that one. There is the AMBI draft that Jake is going to provide an update that he's going to present, tell us all about. And then there's the beer entropy data center draft that Mike Zhurong are going to present. Okay, so first up, Hitoshi. Now, I did post your latest slides, but I also posted the latest slides in the agenda slide, and it wasn't the latest, so it's possible that it didn't get updated. So be prepared for it not being their latest slides. Go back. Do the mtrace one. Yeah, it's missing stuff. Let's go to the other web page. Where's the data track? Go, click on the Mboned agenda one. Yeah, right there. Yeah. Yep. Let's click on that. Did that not do anything? No, that's not it. Can you go back? Go click back on the agenda.
It's just the agenda.
Yeah, but just try it. It might. Oh, yeah, you're right. How do you get to this page?
You have to be in the materials page. It's usually the right side of this, right? It says materials. And it's not showing it here because I'm not logged in.
Here.
Let me try this. Not using the working group materials.
Yeah, but it might. It's a good thing we have extra time. The working group or the?
Hey, stupid working group chair question. Would Mboned actually, do the work for any operational document related to beer?
Actually, it's a good question. That's come up before, and I believe it would apply. I don't think there's anything in our charter that prevents.
But we
us.
haven't seen anything yet, right? So
No,
operational.
we haven't had any ops requirements. I mean, I envision it'll happen. Part of the discussion came up in like, what does beer do now that it's got?
I'm just trying to stall here, so it's fine.
All right, no need to stall. No, but that's
Interesting conversation.
That's actually a good question about beer, but maybe we'll save that for when Mike, because there is a good question, and maybe you can give us at the end.
Sure.
What is the state of beer, and are there operational considerations
Sure.
that we should be providing here?
I'll shoot from hip. I can read that one.
Hitoshi, I think this is you.
Okay, so this is now it's
have previews here.
The next page.
Well, we studied, so this
Push
is.
that again. There. And then just,
This is the history.
yeah, turn it on.
Yeah, no, it's on. Okay, so this is a history of our status. So we studied the ISG review on January 20, so this year, and the version was 22, and we got several comments from ISG, and we revised based on the several comments and submitted version 23 on April to address all comments. But mainly normative wordings or IAN-related things and so on. So except media and ELIC all approved, I believe, but we had still comments from media and ELIC, and we revised based on their comments and submitted version 24 in June to address their comments. And media approved, but ELIC couldn't. So we have been working to fulfill the requirements Eric showed. And so today I just briefly summarize the status and the current situation. And I go to the next, but maybe just go to the last slide is better. The last slide. So actually, this is update on this at this morning. So we thought after Eric's confirmation and approval, we will submit new revision 25 and ask the final procedure. But I met him this morning, and finally I got his confirmation and approval. So now I believe we can submit the revised version, and that revised version will be approved by all ISG. So this is current news. But so if there is no consensus and there is no approval, I may want to ask you how we can address this comment and how we unstack the current situation. But luckily, I got a consensus and approval. So actually, as a result, maybe I don't need to ask what should I do now. But anyway, I can summarize what we have been working. So in the previous slide, you have some question or comment?
Stig, no, I was just going to ask you, if you would say something about what you had to change, what was needed.
Sure, of course, yeah. So this is just a result. I think it's better to show the final result, but now I think it's it's great. So, but let's go back to the page maybe 3.
You removed all the suspense now. Now it's
We go back to the beginning of the change.
Page 3. Yes, this one. So his comment has he has 2 comments. One is forgery of responses, and so it's mainly security related stuff. Forgery of responses, amplification attacks. And he said, this program does not appear to verify that the sender of the request actually owns the IP claims. So anyway, so no, keep it. Yeah, this one. And because the responses are much larger than the queries, this allows for amplification attack, especially if the client is able to send a query or request that it smart replies. And because the query ID is so short, an attacker can generate. Okay. Well, so he requires something like a longer query ID, but we already replied that the query ID is not intended as a security protection mechanism. So the length of the query ID is meaningless to protect something from the security threats. So the first part is actually the main point. So we updated, based on his comment, we updated the forgery of responses. So, well, he may require something like an encryption mechanism for the messages, but we don't want to adapt some special encryption mechanism. Maybe it can be, but that kind of specification could be specified in a different documentation. So we don't want to say the encryption mechanism is something like a must or should. So we explain that the encryption mechanism could be fine, but that kind of part is out of scope of this document, and he understands this part. The second part, this is more sensitive. So filtering of clients, and so see, this one is a version 24. This includes the version. This section subsection is included in version 24, and also in 25 we slightly modified the wording from 24. The LED fonts explain the differences from the version 24. And the answer, the reply from us is that we should specify some configurable packet filtering mechanism is must. So because maybe it's better to explain with an example. So let's say we have one client, and this client is attached to router A, and router is upstream is router B and router C and so on. And the router C attached to the sender. In that case, client send a query messages legally. So he is a valid member. He sent a query message, and router A accept his query and translate this query as a new request message. So request message is transferred from A to B, and then B to C, and then C change the header part or the message type from the request to reply and send back to the client. This is ordinary case. But his concern is if the valid receiver is attached to, let's say, router B, and the router B intentionally or unintentionally sends a request packet, not a query packet, request packet. But router B only approved his IP address, so he sent this request message to upstream routers. But in that case, request message may have some problem, for example, over the MTU or something. Then the error message is transmitted to the original client, which is attached to router A. So this is something like a amplification attack, he said. So this is amplification attack, he says. So this kind of attack, or intentional or unintentional attack, cannot be protected by any mechanism, which is because by any previous mechanism. But to protect this kind of attack, we specify configure packet filtering mechanism is must. This means that the router should also recognize a type value as well as IP address and port number. Then the router thinks that this request message must not be given by his downstream nodes, even though he is a valid member. This kind of intentional or unintentional message must be dropped at the router B. Otherwise, router B just believes his request message, which must be strange, and transfer to the upstream router. So to protect this kind of attack, we should provide some configurable packet filtering mechanisms that supposed to verify IP address, port number, and also the type value of the messages.
Interesting. I got lost a little bit. So does the filtering need to happen only in the actual Mtrace client, or like in the Mtrace code, like the processing code? Or are you saying that a router that is kind of just on the path to the IP destination will need to do some filtering?
Say again?
Yeah, basically I'm trying to understand.
Okay.
Is it just like when a router processes an Mtrace packet, like as part of being Mtrace client or server, whatever, that you can do this filtering? Or do you expect like a router that forwards IP packets to see, oh, this is an Mtrace packet, I need to maybe drop it?
Well, the client, which means and the hosts, only can initiate query, not to request or reply. Okay,
Yeah.
but let's say there's some valid or invalid client, which is just a host, not a router, may send a reply or request message. This is something like bogus. This is something like attack.
Right.
And in that case, the problem is, so this is a little bit complex. So if the query, the request, let's say, okay, so the first, the client send a query, and the query query packet is now transferred to this request by router, and this request is hop by hop transmitted toward the sender, okay? But in that case, the request append the response block. So the packet size will be increased hop by hop.
Yeah.
And in that case, in the middle of the path, the packet may encounter the MTU limitation. In that case, the current packet, request packet, is transmitted to the original clients and continuously eliminating the previous standard response blocks, only keeping the message header, whose type is a request, continuously transmitted toward the sender. But his concern is if the message itself is really larger or the MTU itself is really small along the path, then the incomplete reply message may be transmitted by each router several times.
Okay.
So even though the client send one single query message, he may receive the multiple replies, which is created by the intermediate routers. This is an amplification attack he named.
Sure. Yeah.
So to avoid this kind of attack, intentionally or unintentional attack, request message must be originated by intermediate router, not any host.
Okay, so I think then in basically when you implement mtrace as part of your mtrace processing code, you have to implement some kind of check to see. If
Yes. Exactly.
But if it's just some random router that just see this packet on the wire, it doesn't have to do anything, I would think. My concern is, when you say like packet filtering and stuff, it kind of sounds like it's like an ACL that drops the packet, like, when it's on the wire. But this is actually in the mtrace code, I think.
Well, but this is actually the really similar to the ordinary regular access control ACL mechanism. The difference is that ACL only support to filter the IP address and port number, but as well, the message type must be also checked.
Yeah. My concern is, I don't think you would get all routers on the internet to have the capability of filtering packets based on the.
This is his requirement.
But if someone implements mtrace version 2, then they can certainly implement code that can check, okay, is this IP address an okay address?
Right.
So is it sufficient to do the latter thing that only the routers that implement mtrace version 2 need to filter packets?
But I heard from Kerry's now, I think he's.
Terry's trying to.
Yeah. Okay. So he said there is some vendors implementation corresponding to this kind of filtering stuff, Cisco or Juniper. So he may say something.
Carrie, if you want to speak. Is there something we need to do for him to
It's
speak?
okay, I can try to look at it later and understand it.
Just click anywhere. Just keep pushing. Oh. Yeah, it doesn't highlight at all. Is there a speaker button? Translate to English. Can you ask your question?
Okay. Oh.
So anyway, he said there is such kind of implementation, the something like a common implementation to filter out the based on the message type or something. So that kind of filtering mechanism can be adapted for this kind of schema.
Yeah, but at least though it might mean that you need to upgrade all the routers with new code that
Well,
can do this, even if they are
possibly,
not explicitly, need to support mtrace.
Possibly. But anyway, so this is, and also,
It's going by fast.
okay, so anyway, if you don't agree this kind of sentence, please say in the mailing list or.
Is this what Eric required
Yep.
in order to get thumbs
Yep.
up?
Yep.
Okay.
Yeah,
And Stig, you're not agreeing. You have concerns that it requires all the routers to upgrade, but do the routers have mtrace v2 working now anyway?
Yeah, so at least in practice, I mean, you could say people must implement some filtering to support the spec, right, to be compliant with whatever the RFC will be.
Mm.
And you can say, okay, if you implement mtrace, you need to be compliant, of course. But it's, it's hard to enforce and say that all routers that are deployed need to support mtrace filtering. And if that is needed to make it secure, then in practice, you can't really expect that to happen.
Okay, but this is mtrace v2, and does mtrace v2, don't they need to upgrade in order to support this?
I mean, you need to upgrade. Of course, when you are doing the trace, each router on the path with this beginning of the trace towards the destination need to support mtrace.
Okay.
But you need also routers then between the client and those routers to also, they will forward a packet as well, either the query or the responses. And I'm wondering, do they need to support filtering? But
Maybe it's worth taking that to the list just so we can continue on. How did they say how to grant him the floor?
Oh, it said, you press the big red button. Never push the big red button. I thought that was the only to you.
Okay. It's a great big red button, but it's not labeled.
No, it looks dangerous.
See, seems like you shouldn't use the big red.
hi Kelly.
Okay. Go, Carrie. You can speak now.
Hi, can you hear me?
Yep.
So there's standard functionality that's, I'm sorry, was someone just talking? Okay, there's standard functionality that is supplementary to ACLs that's provided by Juniper and Cisco and I assume other vendors that provides generic packet filtering. And it allows specification of an arbitrary field within the payload, which in this case could be the mtrace message type. So this isn't a special thing required as part of the mtrace implementation. It's just there for current releases of a number of vendors' routing and switching products.
Thomas Eckert, I guess arbitrary within the data wouldn't even be necessary, right? I hope that the message type is somewhere in the first, 32, 64 bits or so of the message. That's typically what I remember everybody supports.
Yeah, that's right, Charles. So it's within not arbitrary, but some number of bytes of the header, which in this case will work fine. We can differentiate request and reply from other message types. So we can say only these ranges of IP addresses are allowed to send a request and or a reply message.
So, Carrie, just to understand, this is Stig again. So it's not sufficient to filter this when you process a query or response. You actually need to filter it when you forward the packet.
Yes.
Okay.
So it's a per interface required configuration on routers that are being used for mtrace.
only on routers used for mtrace.
Correct. So the configuration, although the functionality would, I assume it's there on all the routers in the network. This filtering only needs to be configured on routers that will be participating in mtrace.
Okay, that's great. But doesn't that mean now that just as part of normal mtrace processing, you can say, oh, did this message come from an acceptable IP address?
So at first, that's what we were thinking. So we were just going to provide ACL filtering, but there was a amplification attack scenario that Eric suggested that really requires us to additionally filter it by message type, which is that we have a allowed routing peer that has been explicitly enabled by IP address, but instead of sending a request, I'm sorry, we have a client that is allowed to send requests, and the client sends, I'm sorry, it's allowed to send queries, and the client sends a request instead.
Yeah, but that mean though that all you do is, in your mtrace implementation, you just check, okay, this is like query, does it come from one of the allowed carriers? Or if it's a response, does it come from an acceptable, whatever the word is. You see what I mean? When you process the mtrace message, of course, you know what type of messages it is. So you can make that decision.
So maybe for clarification, and maybe that helps with Stig's question. So try to remind me if these packets that we need to filter are guaranteed to be at the process level because they've been punted by router alert or something else, or can they be in the hardware forwarding plane and need to be filtered there?
So we want to prevent them from even getting punted. The reason for using the filtering mechanism is we'd prefer not to even interrupt the CPU with disallowed packets like this.
We're quickly running out of time. We've eaten all the extra time that we had for this. So yeah. Can we take some of these things to the list, and can you quickly go through the other?
Yeah. Okay.
Maybe summarize them because
Actually, this is the most tough part actually. So next one is just an explanation about what is application attack, and this is also related to the such kind of filtering mechanism. So PIM itself, for example, PIM-SM or PIM-D and so on, has a mechanism to authenticate the neighbor routers. So in addition to the such kind of filtering mechanism, PIM router, this one says should stop any MTLS2 request or reply message that is received from a non-authorized PIM neighbors. And additionally, this is today's agreement. So this initially we didn't mention this kind of scenario because MTLS doesn't rely on any kind of multicast routing protocol, but he requires such kind of authentication mechanism. So as an example, we explain about the PM authentication mechanism, but not only PM, we also need to explain the intent of this text is to prevent non-router endpoint from implementation of non-PM protocol should employ some other mechanism to prevent this kind of attack. So if you use non-PM router, then something like a similar mechanism must be considered.
Okay, Stig again. I just want to say quickly, so, it's great that he accepted this, and maybe we can, be fine with it. But I think we need, to spend a little bit of time in the working group just to make sure that what actually was agreed on is practical to implement.
So the hostages have been agreed to be released, but we're not quite sure we agree with the terms of the release. Okay.
Okay.
I think it goes without saying we should definitely send things on list when people have a chance to really review and digest what was agreed to make sure that it didn't change anything.
Okay, so we will submit anyway version 25, and then after submission, then please review the US version and
The
I think at this stage in the process, right, accept or propose something better. Right, so
Yes.
just raising concerns, I think we're past that.
So hopefully, I mean, you know, it's like they say, the 25th draft is the charm, so.
That's just a little tough.
All right, Mike, come on down.
Come on down, Mr. McBride.
And thank you, Hitoshi, for your grit and determination in getting through this process of 25 different provisions. It's been a long journey.
Very good. All right. So some of you may remember this draft from, thank you, from years ago. Last IETF, I mentioned that it was resurrected. It was already a working group draft. We thought it would be a good idea to have a working group draft here in Mboned that discusses multicast's use in the data center. Last IETF, it was just me on the draft. I requested someone to join me, and that request was granted by Olufemi from Arista. So he did a great job of fairly significantly updating this draft with some new information. And
Doesn't actually work.
yeah, just move it. It's just move to the next slide. That's all there is anyway. Yeah. All right. So basically what we added was things such as things that may not even be necessarily multicast related, but more one-to-many related, whatever that may be. So we addressed things like head-end replication. We introduced just a few things that in the future could be used in the data center. And this is where we would need to get your feedback here. And this is something that was mentioned at the beginning of this meeting. And that is that we included just a brief comment about multicast and segment routing. We just mentioned that in the spring working group, for instance, they are rechartering, but multicast continues to not be included in that charter. And so we need to have a place to address multicast in spring. We're addressing some of those things in PIM. Within Mboned, it'd probably be a good idea to start at least thinking about some ramifications. And in beer, right? Okay, very good. And so we're addressing that. We mentioned beer in this draft as well. Just what's being worked on. Even though, as far as I know, there's no beer deployments in a data center. Is that a correct statement today? Would that be accurate? That you can talk about. So that's not true. So there
production beer deployments outside of data centers? Okay.
So
Should we be doing things like a problem statement or a requirements draft for beer in spring? I mean, for multicast in spring?
maybe so, because we have, for instance, in PIM, a draft that's going to be mentioned today. And we've had some that were discussed previously about different solutions for multicast in segment routing, whether that's beer or some new type of solution. So maybe some of those things may need to be discussed from a deployment perspective here.
It's a stick. Yes, I was wondering a bit what you want to do with this draft. Should it talk about, what people have deployed, like best practices and stuff? Or should it talk about also like issues people see or like future technology, possible new solutions? We kind of do a little bit of everything right now.
Yeah, prior to this latest update from FEMI, it was just what's been used today. Up to this point, where Martica is used, but we added a few just little tidbits that maybe we shouldn't. Just an FYI, there are some new developments that are being used. They're coming into deployments probably soon. Just be aware of them. And when that does happen, here's some of the basic things to be aware of. If that's something and that's what we've added. So that's kind of the question, if we think that kind of information should be briefly mentioned in this draft as we've done, or left out entirely.
Yeah, at least I don't have an opinion really. I mean, I think the document is good, but at least think about, what you want.
Yeah, okay. I think we will focus on keeping it to what I just mentioned, that is current deployment of multicast and data centers. But again, we can't help ourselves by at least mentioning some of these new technologies coming along. So anyway, we encourage people to look at it further. We're not ready to ask for a working group last call. We're going to continue to develop this. We're in no hurry, but I think it could be useful, especially with this latest update. And any questions about that further? If anybody wants to join in on the fun, feel free to join us. Thank you.
Oh, don't go anywhere.
Oh, yeah.
Is this you or?
This will be me, yeah. Maybe both, we'll see. Let's see if it works. Oh, yes, this is. Yeah. No, it's not doing it.
Oh, you just want to present. Now you're presenting.
All right, you're just gonna have to,
It doesn't step through.
no,
None of it does.
so much for that Chromebook.
What happened?
Pushing buttons, well, eventually-
Yeah, just keep pushing buttons.
Eventually, one of them works.
I tried down.
Let's try this. Let's go back to this. Let's try that.
I don't think we're gonna use that Chromebook
Is it?
for our meetings. Yeah, it's really helpful.
You're doing things we never thought we'd have to do. So,
All right, let's start. Try this again.
And just keep it on that first slide if you get,
Yeah, maybe
if
not.
it opens up.
There we go. All right.
Okay, yeah, if you could actually go to the first slide, that would be helpful.
Back to here.
Yeah, that's good. So hopefully you can see this. So a few of us, including someone at Alibaba, thought it would be helpful, per my previous comments, to address beer considerations in the data center. As beer is getting more popular, and as we discuss beer with customers, in some cases, we need to convince them of the benefits of beer, and they understand, the state saving and all that. But we found that it would be helpful, and I think that's part of the Mboned charters, to do these kind of deployment and consideration documents to just kind of help people have something to point to where this is what you'll get if you do use beer. And in this case, we could either have a general beer in a data center draft here in Mboned or beer, or we do like what we've done here, and that is we've just chosen a specific feature of beer, and then in this case, it's including entropy in beer for load balancing, and create a document about it.
Yeah, just for technical clarity, what you did was you selected a use case in the data center and then looked at how to apply beer for that use case or that problem.
Exactly. That's exactly.
And so just using that framework, that's kind of where Mboned belongs in a deployment mechanism for multi-point services. But you're presenting this in beer as well tomorrow, correct?
Just for kicks and giggles, but yeah.
And you should. I mean, we normally do that across working groups to make sure everyone's informed. Clearly, the entire beer group is not represented here. People might have issues about how the entropy is work. I mean, I like where this is going. I don't necessarily agree with all the decisions because I've got some feedback into this as well. We'll take the rest of the room.
Okay, that sounds good. All right. Okay, next slide. The problem statement. So if we can get there. Okay, very good. All right. So
I tried. Oh, it's that one, not that one.
So this draft describes, and Jingrong's been leading this, and these are his ideas, and I've just been kind of helping him with some of the details of this. But we're describing how beer entropy can be useful in data center clause networks. So beer entropy in general is being used with a variety of protocols, including segment routing. There's a draft on entropy. I don't know the RFC number. Yell it out if you know it, but that allows you to do load balancing, and it can be done in a more deterministic way rather than just more of a random hashing in ECMP kind of environments. And beer includes the entropy as well. So you can actually have, as you look at a packet and look at the source IP, a destination address, and maybe the port numbers, you can take that out and create an entropy label in an MPLS environment and hash on that.
Just hold a second, just question. I'm been trying to stay clear of data centers. There's so little oxygen. But any example of kind of the worst case multicast in terms of, to think of an application where, getting this right is most important?
Do you have one?
Nope.
Professional media.
Okay.
Where, like your description here, Greg Shepard, Cisco, as not chair had. You said long-lived elephant flows. In PMN, they're all elephant flows. And so when you've got multi-point going up, multi-point coming down, ECMP could create collisions based on the addressing hash, whereas you want to make sure that this flow takes this link and the next big flow takes this link, and there isn't collisions across that.
So is that typically kind of streaming out of the data center or kind of the
all within the DC?
Inside?
All within the DC.
So processing.
Exactly. So
Okay.
you've got, so even, what we call a DC, and that could be in a truck, it could be in a stadium, it could be in a massive data center facility, but the flows are the same. They're all 4K HD cameras, and they stay that way, uncompressed flows.
Yeah, I think the important part that you mentioned is the data center doesn't have to be the Alibaba big
Sure.
thing, right? But it can be arbitrarily low, small, and the smaller it gets, the more important.
You basically you've got leaf and spine. So, two hop, you're trying to just do two hop deterministic ECMP paths.
Yeah, that's exactly right. Exactly. So that's what a clause network is. And so without going into too much in detail on that, and we mentioned it in this draft, and I think I may mention it more in the DC deploy draft, and that is, how we used to, for those of us who have been doing this for a long time, we used to have the hierarchical tree-like structure, tier 1, tier 2, tier 3, which was core distribution and access, and we've kind of moved away from that. It's much more popular to do these clause spine leaf scenarios where you've got tier 1, tier 2, tier 3, the spine being tier 1, the leaf being tier 2, and the top of rack being tier 3. And it's more horizontally scalable. You can add new servers, devices, routers, whatever, to the spine as you need them without having to replace boxes. So it's just much more scalable, and that's for port density. That's why we're doing it. And we've, kind of mentioned the long-lived elephant flows. They may affect performance of the short-lived flows and reduce efficiency. And there are some hash function inefficiencies in ECMP, and you could have frequent flow collisions, and more flows can get placed over one path over the other. And isolating faults with multiple parallel paths in a data center, and there's a lot of them, can be non-trivial due to lack of determinism. And so we're trying to specify that beer with entropy can give us a level of determinism to help alleviate some of these problems. And an operator may want to have a deterministic path. And this is something that's being used elsewhere. There's a draft MPLS Spring entropy label, which addresses very similar thing. We've utilized some concepts from that draft. And so basically, a deterministic path can be found by using part of the 20-bit entropy field. Bit 0 to bit 2, for instance, of the entropy label can represent a value of 0 to 7. It can be used to select deterministic paths from 8 equal cost paths. So again, it's something that's not new to beer, but thankfully beer does utilize it. It's mentioned in the beer drafts in not any particular great detail. And so in this draft, we intend this is just a first stab at it, but we intend to provide some more of that detail of how you could use this in a data center network. Any questions so far? Okay, so I'm just going to quickly go through the next two slides. It just kind of shows what I just described in this, and these diagrams are used in the draft. So Go back up one more, Greg. It just went down
You're
one.
asking way too much.
Yeah, there we go. They're right there. All right, so this kind of shows, in clause networks, there's 3-stage, there's 5-stage architectures, and you have northward stages and you've got southbound stages that have a rich amount of equal cost multipaths. I've already mentioned some of these problems for steering inflow flows and path divisions to different SIs. Okay, next. 4, yeah. Yeah, it's hard, I know. We're not gonna use the,
Every time I touch it, it's something different.
okay. All right, okay. And so again, by using the beer entropy, you can be able to provide more deterministic path selection. And you can use, like I mentioned, in stage 1, for instance, use bit 0 of that 20-bit entropy label to represent red and blue paths. And you can, on different stages, in this case, stage 2, use different bits of that entropy label to represent 3 paths to each of the different clusters to be able to provide a deterministic equal cost multipath along a data center multi-stage network. Next slide.
Good.
Yeah.
Shepard, Cisco. So in this, you're showing how to potentially break up the entropy field to set deterministic paths.
Mhm.
The question I have is around where the beer header gets written in a way to use these paths. So that would have to be, I guess, below stage 1, or it could happen either way. I mean, if you had IP multicast at the pod level and beer in the DC, it's the first imposition point creates that field, right?
Yeah, that's correct. So in my view, it would be in stage 1. It's a local decision that's being made. And so
Stage 1 being the pod, so you're doing imposition at the host level, or you're talking about at
I guess it could be I wasn't thinking of host level. I was thinking in the pod, but I
okay,
suppose
so it's
it
IP
could-
multicast from the host into the pod.
That's right.
Now the pod is aware of the topology decisions. So just without taking away your thunder here and going
Yeah,
forward, this could be a DC specific decision on how the bits are used, right? Could be just network or like beer domain decision. Not necessarily we have to have an architecture doc that specifies the bits to be used in this way, but here is a particular way to use those bits and how you cut them up based on how many ECMP paths, the complexity of your topology. You can set a beer-wide specific configuration.
You sure could.
Okay.
Using controller or whatever to
Yeah.
make that happen. That's right. Exactly right. Okay, so next slide.
Mike.
Yes. Okay, we're just about done. We're done. So go to slide 6. It just kind of specifies some of the forwarding procedure using beer entropy to select the path over equal cause paths. I already explained that this draft defines a method, use part of that 20-bit entropy label. And it should be easier and should be more granular and more deterministic than using just the typical hashing ECMP function. So with that, I was just going to leave it at that and just kind of go on. But I think it would be good to have a discussion about if this is something that this type of, whether it's this draft or not, this type of topic is that this is something that we think that we should work on here in Mboned. Question.
Yeah, Thomas. So I think, the most simple but, problematic reference example to show, to have people believe in the problem, right? So I think starting with what, Greg was saying, maybe, the smallest kind of data center, right? Which could be production truck with a bunch of, small stuff and then video, whatever it is, right? So that set the expectation in terms of, yeah, this is a problem. And then the other things are fine. I mean, I completely forgot the details. So do we have polarization in the beer ECMP? That's one of the typical issues to deal with, right? I don't remember it in the algorithm. Obviously, I also stand out on, behalf of this author of BeerTE and say that we haven't thought about really that much about the ECMP stuff. It was obviously mostly about non-ECMP path, but we could also think about comparing this, what we can achieve with the beer ECMP with the explicit hop-by-hop engineering of the path in the data center with BeerTE.
Oh,
right?
BeerTE. Okay, specifically. Right.
Yeah, right. So I mean, I think there are options. I would start with the, do you buy into the problem statement with, the best possible reference example we can come up with. Because, if you buy into the problem statement, what else can we do than work on it, right? So.
Yeah, okay. Thank you. Any comments about, well, maybe this is a shared discussion, but this being worked on in beer or in Mboned? So,
Gotcha. So the question is this, so who's read the draft? Who feels this is material that should be adopted as working group item?
In this working group,
Well,
or any working group.
yeah, that's a good question. Jeffrey, I'll like your input. Yeah, go ahead.
Jeffrey from Juniper. If this involves defined methods of using the part of the entropy field in beer, or the beer entropy label, well, can you first clarify if this on this slide you mentioned use part of the 20-bit entropy label? Are you talking about entropy label, or are you talking about entropy field in the beer header?
do you want to answer that, Jingran?
Entropy field in the beer header, of course. But generally speaking, entropy is followed with a label. It's a 20-bit value, just a 20-bit value.
Okay, so if this involves beer entropy field and also involves some specific beer forwarding behavior, then I think it should be part of the beer working group. Another comment is that if you want to control how the path that the packet follows, another way to do this is use multi-topologies or just flexible algo, so that you can decide that some package follows one subtopology, some other package follows a different subtopology. That's another way to do it.
Right. I'm going to address that one in particular because I think the use case that I'm thinking of that kind of came out from reading the document is specific enough that multi-topology, it would be very complicated. You would have to have several of them, not just a couple. And we're not really trying to select topology necessarily. We're trying to ensure that each of the hops don't have collisions. So you could build complete matrix of topologies to ensure that's the case. But in a flow-by-flow basis, you may want to make a different determination that this link was okay now, but now at the next hop down, we've got a congestion issue. I want this to keep on this hop, but take the next one over here to avoid that congestion. So that's what I mean by this matrix of topologies could get very complicated quickly. So I think to Torlis's point, maybe a more specific problem statement would allow to burrow into a solution that is very specific to that problem.
Stig, I agree that this should be done in beer, I think, because it does, seem to alter the beer forwarding in some way, right?
So you're presenting us tomorrow on beer?
Yeah.
For more than just courtesy now.
More than that, it
Dress
sounds
up
like that.
better.
Yeah.
You can wear something better for that?
No.
So Torlis, it wasn't kind of clear to me, if you're really changing something in beer or just basically, what an application using beer and setting the field would be doing. So might be borderline whether it should be beer or Mboned, but overall the problem statement, describing the example reference problems. So anything operational would be good here. So, I mean, I have no strong opinions either way, right?
So I don't remember now, does the beer specifications say how to set the entropy, exactly how it should be calculated, or is it left more or less open?
I think it says it's out of scope in the document, but we should double check that.
But yeah, if it doesn't, require changes in beer forwarding, if it's more how you set that value, then it's not that clear where it should go.
Yeah.
Right.
My
So specifying how the value is set versus specifying, well, it's kind of both, really. But instead of the entropy field pointing to an ECMP table, it points to some deterministic table that's effectively ECMP, but it's not built on hash, it's built on some predefined topology.
Okay. I think-
So yeah, we're running out of time, but did we need, so you're just going to present, so why don't you
Yeah, let's
present
go from there. and
at
then we-
beer and then see, the good news is we have a common co-chair
Yeah.
for both, so Greg, you can kind of
we can-
lead the charge in determining
We'll
where
figure
this
it out.
belongs.
Thank you.
All right, next up, Jake, I hope you don't mind. We're gonna move Natalie up ahead of you, and she's gonna present on her experience in AMT Gateway Implementation Building in VLC. So Natalie, are you there?
Yes, can you hear me all right?
Yep. So just in London, we had William Zhang present his experience in deploying an AMT relay. One of his pieces of feedback was that, okay, the relay's up and running. There is content out there. However, the state of gateway implementations is not so awesome. The best, most widely usable implementation was a VLC Windows port that was about 10 to 12 years old. So Natalie has been working on examining the best strategy for deploying gateways, and she's going to talk about her experience, what led her to VLC, and what how things have been going.
All right. Excuse me. So yeah, Lenny explained the background for that a lot. So you can probably just go to the next slide then. So the end goal of the project was to allow end users to access multicast content over the internet because it's out there, but there's not an easy way to get it. You kind of have to do a lot of workarounds. And so I made a list of various ways that we could do this so that in the end it would be easy for even like my mom to use, who she kind of struggles with technology. Because I don't want it to be she has to enter an IP address and like go through all this stuff because she, something goes wrong with her email and she's like, I'm done, I quit. So I've been doing that since the end of May. That's been my project at Juniper, and I had no idea what AMT was before this. So it's definitely been an experience. You can go to the next slide. So again, I made a list of a bunch of possible platforms. Our original goal was to use a web browser implementation because that tends to be the easiest for people. I mean, you go to a website, you like click and it's there. That's really easy for most people to understand and use, but I did find some issues with that. So with WebRTC, at least from what I found, it had no multicast support, and then WebAssembly had no UDP support because AMT works over UDP. Without that, it just doesn't work. So then I looked into making a plugin for a browser like Chrome, Firefox, and then, making it available to all of them. But I found out that Google apparently deprecated plugins starting in like 2016. They had this like movement, and then it kind of like finalized in 2018, where plugins, you can no longer create new ones, even though older ones can still be maintained. So I didn't want to start on making a plugin just to have it be, completely out of date soon after, and other issues arise with that. And then I tried an extension, and the gist of it was that anything to do with the web browser there's no raw UDP access. So, oh, I'm sorry, was there garbled speech?
Nope.
Oh, okay. I'm sorry, I don't know why it's echoey.
We're not hearing an echo if that helps.
Okay. But with the browser implementation, there used to be an API for accessing UDP sockets, but it has been put out of date, or like when I even just started on some of the tutorials for like writing a plugin or something like that, I kept getting all these errors about like, hey, this is deprecated, you shouldn't use it, like try moving to something else, but it's newer. So there's not an API, and it's understandable from a security standpoint. Just accessing raw UDP sockets, but they're also Google is pushing progressive web apps, which then it seems like Mozilla was following suit from the stuff that I read. And there's, again, still no UDP support. So I settled on VLC integration because VLC is essentially the most widely used media player that isn't the default, because a lot of people, when they have issues with their media player, if they go to Google and search for something, VLC is like the next thing there. And it already has native multicast support, and it's available on like all platforms. Like they have a port for basically everything, and it's backwards compatible for like all their old versions and stuff like that. So and theoretically, I actually found this out more recently. They also have a plugin like that has already been made. So theoretically, if the AMT module got added in, then you could make a web application that could use that plugin, that as long as everything gets pushed upstream and such. So you can go to the next slide.
Still there,
Next
Natalie?
slide. Oh, can you not hear me?
You kind of trailed off there the last 10 seconds.
Oh, I'm sorry. What was the last thing I said?
We didn't hear it.
Sorry.
You ready to go to the next slide?
Yeah.
Okay.
Hopefully this works out better. I think
sound
it's
is getting
using
better.
the
It's
default
not
mic, but I'm not
really loud.
sure what. Is it better?
Yes. Yeah. Now it's good.
Okay, cool. So the other benefits of VLC, it handles basically all major media types. It can play almost anything, even like corrupt files, which is really good. It's also modular, so adding parts into it and like developing on its source code is pretty easy, because you don't have to worry about breaking it, the other functionality too much. And again, it runs on almost any platform. I found that it's pretty easy to use from my standpoint, but then again, I'm also, a computer science person. It could possibly be easier to use for people who don't, but it's still got a lot of instructions out there in terms of how to use it. So you can go on to the next slide. So what I did is I started on an access module. VLC has all these kinds of modules that work for different things, like output, access, demuxing. So most of the demuxers are actually what decodes the streams and stuff like that. So my idea was that I'll create an access module that essentially, opens the ports, sends the correct messages, the discovery, advertisement, and such, and then pass that data onto a demuxer, because theoretically VLC can already read whatever the data is, because it should be a major media type. It shouldn't be something ridiculously obscure. I did start off using the UT Dallas AMT implementation. I kind of looked at that first only because it was, already integrated with VLC, quote unquote, but it was also from a much earlier version of VLC that wasn't quite as modular then. So it's helpful-ish. It was also mostly, it had a lot of Windows API specific stuff, so it wouldn't work as well for compiling with VLC. Jake Holland, both his code and just talking to him over email was really helpful for me to understand, and also just where to get started, because VLC is just really big, even though there is a lot of documentation and stuff. Kind of confusing to get started. Cisco has an open source library for SSM AMT, so that was also pretty useful. Theirs was also, though, intended to, you can like set up a relay and a gateway from that, and some of it wasn't fully functional, so I mostly borrowed from it what I needed. And then the Concordia implementation I referenced and looked at and was using in my initial research to kind of get familiarize myself with everything going on. So next slide. So some of the major challenges, I spent a couple weeks partially doing research to actually understand AMT, but also just the appropriate path, because again, I would keep trying something with a web browser and then find out, oh, it doesn't have this kind of support. Oh, it doesn't do this. So that was a little difficult. I actually did have to duplicate a little bit of the IGMP and IP protocols in order for AMT to work and just getting my messages to send correctly. AMT wasn't understanding it itself wasn't a huge challenge, but it was still there as something I had to overcome in the beginning. Right now, also, where I'm stuck right now is that I can receive the multicast data because I send the messages correctly and like Wireshark shows me receiving the multicast data, but the audio is garbled and there's no video rendering. So, and I've tried syncing it up with the Windows VM I have for the other, the working implementation, and the audio lines up. It's just dropping like packets randomly, and the output from VLC is like skipping 30 bytes of garbage. So I'm just stuck right there because it seems like I'm not unpacking the packet correctly. VLC seems to be confused by some of the headers. I will say it was much easier than expected for me to compile VLC and actually start on writing the module because I haven't actually contributed to open source before. I'm still in college, so I haven't done it yet. So that was much easier than I expected. Next slide. So I still have a to-do list for the rest of the summer. I have a couple weeks left. I do want to add in IGM v2 support because I've been focusing on IGMP v3. I don't think it should be a huge leap from what I'm doing now. I need to make sure I have no memory leaks because VLC, most of their modules are written in C, so I just need to make sure there's no memory leaks. I don't currently have the timers fully working just because of the way I'm receiving data right now, and I was mostly focusing on the actual functionality rather than timers just yet. I mentioned it before, VLC looks like it does have a browser plugin, so I could, once provided this module would be like accepted into their access, you can make a browser plugin that's then easy where, you know, someone clicks on a website and it's like, I want to watch this multicast stream. And when it doesn't work natively, it just does AMT through VLC. The end goal is, of course, to successfully stream full video and audio because there's a relay already set up at Thomas Jefferson High School near here. So, and then later on, submit a patch request, feature request to VLC so that this module will be in their full thing. Yeah, so. Next slide. I don't know. Oh, impressions. So with AMT, again, I didn't actually know what AMT was before I started on this project. At first, I was like a little confused because it didn't fully make sense to me. But then, like, once I like read the RFC and into it more, or some of the articles that Lenny sent me, I definitely think it's really good for solving, as he called it, like the chicken and egg problem, where it's like there's not that much multicast content, or but there's also like not an audience because there's no content, but there's no content because there's no audience. So I think it's a really useful way to help transition into, hey, let's have more multicast content available for as many people as possible. I did think the RFC 7450 was pretty well written. Very thorough. The diagrams were great. So VLC itself, just briefly, their documentation is better than some of the other open source projects that I've looked into before or had to like glance at for school, and their chat and forums were okay. Just from my experience, I had some issues that everyone kind of dismissed right away, and I was like, okay. But it was really easy to start developing, though, based on their guides for it. So I think that's it for impressions. So last slide, I think. So yeah, any questions or comments?
Anybody here?
Cool. Well, thank you, Natalie. You're a kind of an excellent a good case study for this working group because AMT, the spec was essentially written for someone like you, somebody who doesn't necessarily know multicast but can walk in. And so it is good to hear that you were able to pick up the spec and figure out how to start writing an implementation. So that's actually great feedback for this working group.
Greg Shepard from Cisco. So what are your next steps?
Right now, I'm still trying to finish up and actually get the video stream in addition to the audio because it's not fully synced up right now. Like, I'm definitely receiving the data. I just don't think I'm processing the packets correctly. So it's kind of a matter of like checking my sockets and checking that VLC is actually getting the data correct, since again, it kind of jumps through a lot of hoops. So the most immediate one is fixing that, but then after that, it's going through the steps to do like a feature request and like code documentation and all that.
Excellent. Thank you.
Yep.
Thanks, Natalie.
Yeah.
Okay, Jake, you are up.
Hit the big red button for him. Is he going to do it that way?
Well, we didn't need to hit it for Natalie, so I'm assuming it just worked for Jake.
Oh, once we hit the button, it's been hit.
Yes. I
Okay,
think
so
you only
one
hit it once.
Gotcha.
Maybe I can go. Oh, maybe not.
Am I up there now?
There you are.
There you go.
Right.
We have to hit it before you-
Hey, we got video
Yeah.
too.
I held my comments because I knew I was going, but thank you, Natalie. That's exciting work. I'm interested in hearing more about your progress, seeing that end up working. Great. So I'm going to talk about our new proposal for asymmetric manifest-based integrity. This is meant to provide integrity guarantees, cryptographic integrity guarantees for multicast data streams in particular. I think there's no reason you can't use it for unicast, but particularly maybe like AMT would be a potentially useful case to do that, but mostly we're looking for multicast. Yeah, interdomain multicast. We think that one of the issues, it maybe is not the only issue, but I think it's a blocking issue, that we're not going to have a real Mboned with interdomain multicast that is friendly and widely available if we can't make good integrity guarantees ultimately, I think. And so this, to me, we're trying to fill a hole, we think, in what we've got. So you guys know why multicast, but we're trying to solve the interdomain multicast problem. And that's one of the points of feedback I want. If I'm wrong about that, then I would like to understand it and know that. But that's the sort of premise behind this. Yeah, next slide.
Jake, I think, or at least the other folks on the Meet Echo, we see you. I don't know if they see the slides. Do the Meet Echo people see the slides?
They say
Oh,
they
they can?
can.
All right, good, good.
All right.
All right, never
We're
mind.
goal.
All right, so our goals here are about we want to have, mostly what we're trying to solve is live video. That's kind of the main use case we want. And we're looking for asymmetric crypto. So we mostly want integrity, because when we're talking about live video, especially to a wide audience, symmetric key is just not, like, there's no point, right? And we basically want to be able to do it and handle loss appropriately. Go to the next slide. Okay, there we go. So let me preface this, the next 3 slides, including this. We got some great feedback yesterday from SecDispatch. Ecker pointed us at a really interesting paper that I think might be able to improve this or help us improve on the scheme that we have. But what I'll describe here is the scheme that we've got in the draft now. And just take note that we might be able to do a little better. So the basic idea is that there's an anchor message up on the top left. That is the that's fetched usually by unicast, a secure unicast connection, but we say any secure transfer is fine, where we can verify the authenticity, and that contains public keys. The public keys can be used to verify a signature that's part of a manifest. The manifest, in addition to signature where appropriate, has hashes of the data packets that it's authenticating. So this provides proof that, cryptographic proof that the sender, that the owner of the private key listed in a securely transferred anchor knows the data packets that were part of this data stream. Okay, so next slide. Yeah, so we extended this because we noticed that it's going to have scaling problems. So when you're talking about like a 20 megabit flow, you're looking at like 2,000 data packets a second, depending on what kind of security you think you can get away with in your hash lengths. You're looking at like 40 to 100 hashes per packet at most, with a zero length signature. And we're not sure how big the signature has to be necessarily. If you want to use RSA, if you want to, a big RSA, then you're going to take a chunk out of that as well. By making a tree, we can, so this is kind of like a Merkle tree structure here. By making a tree, we can have a signature at the root of the tree, which then provides integrity for child manifests that don't have to themselves hold a signature. And the child manifests then have the hashes of the data packets. So this still provides the very similar kind of integrity guarantees for the data packets themselves through this chain of manifests. Next slide. So for redundancy, of course, we need, you can either retransmit the manifests that you want, or you can send the data packet hashes multiple different times, signed by a different tree in the different times that it's signed. So this is a trade-off of signature rate versus redundancy versus latency of the video stream you're trying to secure, right? So so this is these are all configurable as part of the anchor message to determine like what is it that you're going to be sending, and send it in a manner that matches this. And then as long as you're getting the assigned hashes of the data packets, you can verify that all the data packets you're receiving are the ones you expect, or reject the ones that. Okay, so next slide. So one important piece that's all these things that I've said so far, you can sort of get by Tesla already. Tesla is a spec from a while back, which provides, the way they do it is a symmetric key, but they don't release the key until after everybody has received the data packets. And then they send the key out, and then you can tell that, yes, the data packets that we have are ones that were signed by the key that just got disclosed under a signature. So one of the new capabilities that AMBI provides is that intermediate nodes can provide authentication as well. So you can avoid sending unauthenticated traffic into a network if you put it at your engines. At least that's the intent and the hope. One of the points we noticed was that an attacker in a setup like this, where they've got a way to send untrusted traffic as a man on the side, so you're adjacent to the path, not necessarily on the path. So you can spoof the traffic here, and you can, when you have receivers joined to a stream that you're attacking, you can make a congestion attack, which at the IXP layer might not be a significant amount of traffic, but might still overrun the what the receivers can handle. Next slide. So the way we do that is that the intermediate AMBI system has to get the anchor and be able to process these packets and authenticate them before forwarding them. So the idea is, this is an idea we stole from the AMT relay discovery from a couple of years back that's still languishing. Might be worth looking at again. But the idea is that an SG join is issued. And because we have the source as part of the SG, as the RPF signal goes back to the AMBI node that's an intermediate system, it now can do a DNS lookup on the reverse source IP. And we are, I think it's not in the draft yet, but the plan is to make a DNS type here and to use that to expose the URL for the anchor message. And then the anchor message provides all the information necessary to authenticate all the traffic from this source that is being authenticated through AMBI. So next slide. So next steps, we of course are looking to improve the protocol. We have the our research to look on how to integrate the advice we got from Sec Dispatch so far. The other advice from Sec Dispatch was if we want to talk about opening MSEC, then we need to go find people who are interested in this. So I was really hoping that this audience would be universally interested or close to. I understand some people may not think that interdomain multicast is worth solving, but in my opinion, that is the essence of Mboned. And so I'm hoping that we can look for ways to move this forward. Any feedback, of course, is very welcome. Next slide. I think it's just more asking for feedback. And yeah. Right, the DNS thing, I haven't seen it a lot. I'm interested in hearing if people do have problems with that idea. The sooner we can understand them, the better. Obviously, if this whole idea is just not worthwhile, I would like to understand that as well and walk away before I spend too much time on it. And outside that, yeah, we'd like to make it just as solid as we can. We're, depending on the feedback we get, we are probably looking at taking a stab at an implementation sometime. Maybe we'll have some forward motion before November, hopefully.
So Jake, Greg from Cisco, got a question for you. So you mentioned MSEC. So is there again a bit of a gap analysis to see what what ball do they drop that you're trying to pick up here?
Right. So I addressed that a little bit in the draft. It's under the heading of comparison with Tesla. The basic problem is that Tesla doesn't provide non-repudiation. You can't, and so the issue is that if we want to let both the receiver perform authentication and a network element perform authentication, then Tesla can't do it, because by the time you release the key, either the intermediate network node has forwarded untrusted traffic, or the receiver is not going to get a key, is not going to have the data before they get the key.
Got
Does that
it.
make sense?
Thanks. Yeah. Any other questions? Comments?
On the last one, the feedback on the DNS thing, I think relay discovery, AMT relay discovery is a long overdue topic. like you said, there was the AT&T guys came up with a draft using DNS. Actually, maybe 15 years ago, someone from Sprint came up with a similar way of using DNS. And I think it's worth reopening, not just DNS, but just generally speaking, how do you pick a relay when there's a bunch of them, some of them being Anycast, and do you pick the one closest to you? Do you pick the one closest to the source? Do you pick the most? So I think that's definitely something worth looking at. And I think DNS can play a role in that. So
right. So that's another point. If there is feedback on the DNS thing, there are at least one, that being the AMT relay, and possibly two, possibly another thing that I want to consider using it for, because I think the trick is pretty good for finding a RPF source related thing from an intermediate node. So yeah, if you don't like that idea, then I would like to know why. All right. Well, thank you for the slide. Appreciate it.
great, thanks, Jake. All right, Torless, come on down.
Amanda's no tour.
So you have 2 presentations. You have 25 minutes, scheduled for 25 minutes. Ironically, we are right on track. So
You have 10 minutes, Torless. Tell him 25. He'll take 25.
actually, honestly, you have the 30 minutes after that until Pim starts. So you have until people leave.
Yeah, you have the cookie hour.
But my suggestion is do the deprecate one first, and then do the other. But
Let's try
you
that.
could try. It doesn't work, but you could try.
Okay.
We tried playing a presentation. Try that.
Okay.
You're trying that.
No. Next slide.
No. 2 buttons. You can scroll over here. That's all he gets.
All right.
You need us.
I'm so lost without you. Okay, so anybody still remembers IETF 101? So we discussed basically at that point in time the kind of revised new draft that came out of prior drafts in which we, started trying to deprecate ASM completely, and so we wound that down to deprecating ASM in the interdomain space, but not in the intradomain space. So that was the agreement. Hopefully, basically with 101, the 00 draft of that eliminating the resistance that we had in terms of trying to get all the way into deprecating ASM all the way. And one of the reasons, of course, is that ASM intradomain is still widely used, right? So there is really no replacement for the best form of ASM, BIDR PIM, in enterprises, to replace, 20,000 S, G state with a few group states. And we can still think about, starting to retire more intradomain, I think, operationally. But, really the primary issue from the operational perspective is that it's a really good thing to start deprecating on the service provider side, because that's where basically the service providers have a good impact on getting the applications to move to SSM, right? They run their IPTV shop. They basically are in much better position to get the SSM adopted. While in the enterprises, we've seen that for 20 years, it's really very hard for them to force applications to support SSM. If we're lucky, basically the stuff that happens on the service provider side, SSM-wise, will trickle in the enterprises as well. I mean, these days, what new applications exist? They're all the ones that are being used in the internet now. The enterprise isn't really the place where innovation happens. So that's why I think we're going the right order of, not touching the enterprises intradomain right now. But, even something like Internet 2, if you remember the discussion we had in before, as being one of those networks that's trying to get rid of ASM, that's connecting a lot of enterprises, research organizations, right? So that would, already start going that direction. So that E00, yeah, next slide, I think, yeah. Right, so then basically shortly before 101, too late to bring it up in 101, I provided, a bunch of clarifications and additional operational insight. And so that became version 01. I got onto the authors list there. With explanations like the one I had on the previous slide, adding text to discuss the MSDP challenges and why there is no MSDP for IPv6. So kind of a bunch of the background, providing further evidence of how really dead ASM in real interdomain actually already is. And so maybe we can still rephrase that. We're really not killing it, right? It's basically already dead. MSDP is really used in very few interdomain deployments already only. So please read through the 101. Was there anything? No. So I think the key part of that was the bottom point, right? Expanding the scope of interdomain. So one of the tricks was, what is it actually intra and interdomain? And you can have different views on it, right? One is from the protocol side. So a PIM person will tell you, oh, interdomain, you need to have different PIM domains. But if you come from an operational perspective, it's good enough to say you have multiple administrative entities that are munching around in the network. And that definition, if we take it operationally, really allows me to say a single service provider that has, 1 million home networks with home gateways together is an interdomain case. And voila, I've also made what we're saying interdomain be applicable to the most simple case where we really want ASM out of the picture, and that is a service provider offering IPTV services that goes to 1 million homes, and where you definitely don't want to muck around with PIM sparse mode. Service provider tried it. It took them, in many cases, 6 years to get the bloody IPTV application vendors to support SSM. In many cases, they had to change their vendors to others, but now we're really in round 2 or round 3 of these IPTV deployments, and I would hope they're pretty much SSM everywhere. Next slide. Continued. Right, so and there is a lot more additional stuff. So we added text to also suggest to prefer SSM intradomain when possible, right? And discuss the application dependencies when and where that's not possible. Added stuff to suggest documenting in some BCP for how to develop SSM application to really support this move, right? Because I think there are things that we learned, like how to get SSM into electronic program guides for IPTV applications or whatever signaling you have, wherever you are signaling a group address. Why don't you signal a source address together with it, right? So that would be added work we're suggesting to be done here. Yeah, and then 02 was just fixes, right? Nope. Stop this slide. So. And this is basically the stuff that I primarily wanted to talk about in the PIM working group. So the associated candidate work would really be figuring out how can we get the classification of our standards into shape, because right now, older standards that nobody should use have a better standard level than what we want them to use, like IGMP v2. So that is in a different presentation. And then also, how can we get completely rid of MSDP, right? Deprecating ASM interdomain almost gets the job done. Unfortunately, MSDP is already more or less retired, as I said, interdomain, but it's heavily used intradomain for the MSDP mesh group. And it's actually doing a pretty decent job for that, right? But if we want to kill it, I think we need to basically make the protocol that we actually would want to use for mesh groups, which is RFC 4610, ramp up with all the operational requirements that we have, and that's reliability, debuggability, troubleshooting, and control. What we've learned in MSDP over the years, so the proposal is there. One draft that we have in PIM to basically get us to the transport over TCP for the reliability, flow control between the RPs, and the other one would be a Yang model that somebody still needs to write, or hopefully find a Yang author where we can add it to one of the existing Yang drafts or updating them. The SSM application development recommendations that I mentioned before. I'm not sure what other outcome we want to have on really evolving the standard spaces operationally and protocol-wise of our core framework, but these seem to me to be the most important pieces that we could think about. Next slide. So conclusions. So the authors think the document is really in good shape, right? All the strategic concerns for adoption should have been eliminated, right? And so,
Yeah, so just
I
as-
actually
just as-
overlooked that, so that's,
Yeah.
I was just clueless about the process, so reminders to the list, maybe good, that's great, so.
Yeah, so in London, we did in the meeting, and I think it was everybody's hands were raised in favor. We took it to the list last week, I believe. We still haven't heard from, there hasn't been much replies on the list, so we can't adopt this until folks speak up on the list. So what I would say is, so first off, let's just retake a poll and make sure nobody's mind has been changed in the last 4 months. Who here has read the draft? Anyone? Okay. Who supports adoption of this draft?
Just to clarify, can you remind me what deprecation means? Like, what's the effect of that in the IETF?
Webster's
question, yes.
dictionary defines deprecate as.
I mean, at minimum, I hope it just represents, a statement from the working group, but yeah, I mean, what official, levers can we pull?
Yeah, so we don't have a police force. The best we can do is write drafts and BCPs that say, if you're going to do interdomain multicast, don't do ASM, do SSM. So it is direction to the world that when you deploy multicast. So what does that really mean? Because again, we don't have a police force to, jackbooted thugs that we can send out to Knox everywhere to start turning off MSDP and other things. Or filtering, we're telling people to filter, everything that's not 232/8. What effectively it means is it can help, the Mboned, which we are Mboned. The Mboned does exist. It is the multicast enabled portion of the internet, and it is primarily I2. So I2 is probably 90% of the Mboned. And they continue to maintain an MSDP infrastructure. They continue to support interdomain multicast. And so it would give them the ability to, and this is one of the drivers, to turn this off and explain to their members, this is why we're turning this off. It is best practices to not do interdomain multicast ASM, to do SSM for interdomain.
So maybe 2 comments on that, right? So I think this target status of the draft that we're asking for is BCP. And then I think the way that you pitch this to customers is a BCP is like a standard, not for protocols, but for operators. Right? So, I mean, that's, I think, the simple pitch or so. And it's hard to somebody to challenge it because I think that's pretty true, right? The second one, can you send an email about this, filtering of 232? I don't think we had that recommendation part in it. So it's a good one.
We're not recommending it.
Oh, you don't recommend it?
Yeah,
Okay.
if you remember, in London, that was one of the things that was suggested, and it was nixed.
Okay, fine. Cool.
So yeah, I don't think we want to go that far. It's more of a finger wag than a jackbooted thug coming to your network to turn it off.
Okay.
But another benefit, Mike, is to give clear direction to application providers, people outside of this working group who just think that, oh, we'll just, join a group, that you need to do SSM, that here is, a BCP. BCPs are saying, there's an RFC that officially says, don't do ASM, do SSM. So it helps providers, it helps operators give clear direction to their app developers.
Yeah, and so all the folks who raised the hand, please don't sleep on the email list for the next few months. Say yes when the...
Yeah, well, no, don't. It's not for the next few months. If you want to send an email right now, you can. So when we took that informal poll, it was 5. So that was I believe 5 people raised their hand to support it. Anybody against supporting this draft, who doesn't want to see this draft adopted? Okay, so it's 5-0. Please, folks, send an email to the mailing list that says I support or I do not support. But we need to hear we can't adopt this unless we get enough replies.
The promise is the other half of the working group is co-authors, so that kind of...
Yeah.
All right, next slide,
Any other
please.
questions about for deprecate ASM? All right, moving on.
Right, so this is just for informational purposes. Well, we have the time, so we can talk about it.
You have somewhere between 11 and 61 minutes, depending on how much time
Right.
you want to take.
Yeah, no, that's fine. So let's go through it. Next slide. Okay, so problem statement. So if you are trying to adopt a protocol from a host to a network to signal multicast, what would be the highest, internet standard level of any protocol? This is a Q&A session here. So,
This
So, I mean,
is
you're-
trying to be engaging.
right, I'm trying to be engaging. So, yeah, this is a test. You're
The answer, internet standard?
yes.
Okay, because it's
So
at the top.
no, reading the slide is cheating. So, right.
Is that
So
your own
basically, I'm trying to adopt the best available protocol standard. I'm most conservative, so I'm looking for a full internet standard. That means I can't use IPv6. They only have proposed standards. I need to use IPv4, and the protocol I want is IGMP version 1, which is a full internet standard in RFC 1112. That is exactly where we want to be, right? No, I don't think so. Right, so that's I think the best pitch I can give about the problem statement here.
So V2, IGMP v2 and IGMP v3 never made it to
No.
internet standard.
No, proposed standard.
Wow. Do you know why?
I have no idea, probably because we've all been asleep at the wheel and never cared about processes. Have you been at that RFCI on Monday evening? Kind of process is really not a nice thing to think about. But, after a decade, maybe, just investing a little bit in this process to basically make sure at least that stuff isn't becoming a reason why people do the wrong thing.
Stig, I think this is just like a natural process, or kind of like how IETF works. And IGMP version 1 has been there for a long time. It became kind of mature, and sure, we make it as standard. And of course, in the later versions, they have been around for a shorter time, so it takes time.
Just
Whatever.
in 20 years instead of 30. Yeah,
Yeah.
sure. Yeah.
But I would like to, maybe see in the IETF in general, what happens when you come up with newer versions, like newer protocols. How do you deprecate? I think maybe making it historic.
Yeah, this is the problem, right? So there's basically this poor PIM working group chair or area director that I'm going to ask these questions
Yeah.
in some session in
Yes.
an hour or so, right?
Yeah, so at least my thought would be version 1 should probably become historic or deprecated, but we'll talk to ADs and others to find out. And of course, we need to look at probably, either version 2 or version 3. If you want to make something a standard, you generally need to go through like implementation report, make sure what all the
Well, are you going to say
implemented.
something different now as an individual Mboned contributor than what you would be saying for the same question in an hour? So, right. So, yeah, let me quickly go through the slide because I also had talked with operators, after this, the deprecate stuff and about, we want ASM and SSM, right? So this stuff is related, right? So, so the operators think they do not need to go through IGMP version 3 or MLDV2 as long as they do not need SSM. That is, to some degree true, right? So it would be good enough to stay with IGMP v2 and MLDV1, but they also get other benefits from MLDV2, from IGMP v, okay, typo, from IGMP v3 and MLD, bad typo, okay. Right, so one, for example, is the explicit tracking, which is one of these other issues where I think we also need to point out that, these latest versions do provide short leaf latency, which in IPTV is extremely crucial. And then martyr our brains, what beside SSM and explicit tracking were the other benefits that we get out of the latest version of the protocols. And that's basically something we could write down into an informational draft in Mboned, basically to go along with these standard document status changes.
Stig, I think the main problem that I see all over the place is that people think IGMP version 3 is SSM only.
Right,
That's the main
exactly,
issue.
yes. So if we can have an RFC with 20 type bold font, that would certainly maybe be the best way to emphasize that is not the question.
I could, your bullet there is a little misleading as well. Greg, Cisco says wrong, fully backward compatible can mix 2 and 3. Well, you can do ASM without 2. I mean, V3 supports ASM. It's not like you have to fall back to 2 or 1 to get ASM functionality. V3 supports ASM.
Yeah, of course.
Well, it's confusing. Backward compatible, can mix V2, V3 routers, queries, and hosts arbitrarily. It's like, yeah, you can, but you don't need to. You can do ASM with V3. I'm just giving
Right,
you
right. I think there is a point missing in the middle.
Right,
So
that's
when I
my
was
point.
going-
You're
going
add that
with the
point
customer through it.
I'm trying to help you.
Yeah, no, of course, yeah.
I'm here for you, Torlis.
Thank you so much. Yeah, so the midpoint, of course, you can perfectly go through to IGMP-v3 and MLDV2 even if you have nothing on board with SSM, because your intra-domain, you use BIDR PIM, whatever good stuff you want to do in your domain, don't stick to the old protocol version, right? And then also any mix should work. And now we've seen basically problems in the past, and so I mean that's operational experience that we, in an Mboned draft may want to mention. I would think that, my latest problems with IGMP-v3 went away in something like 2010 when the last snooping switches started to support it, right? So, I mean, if we have some timeline to really give more confidence to operators, that would certainly be not wasted. Right, so, and then of course also, when we are writing something operationally down, then an Mboned document would be the place to state, here are all the changes we've been doing and deprecating ASM interdomain, but we really want to have, a full internet standard for intra-domain ASM. And that's basically around, the other draft I mentioned, right? So the deprecation interdomain, and then these discussions, right? So intra-domain is fine, BIDR PIM is preferred. Majority of customers, I would think the majority of multicast deployments overall, if you just count customers, would still be enterprises that are using PIM sparse mode within the domain. And then obviously all these things, like there's a good range of application that could do SSM, but we're not forcing you now, but whenever there is an opportunity, right? So I think that that statement should be made, because that was exactly why operator called me and basically said he was, afraid about, the work that we're doing interdomain really touching whatever he is doing. And then we got into all the IGMP with discussion, that stuff. So how do we make the majority of what we're still making money from, unless a vendor is just selling to service providers, right? But if I look at these typical service vendors that sell both to enterprises and service providers, we don't want to really make the enterprises feel scared, and so that's this part. Next slide. Right, so now the funny protocol list, right? So RFC 1112. And so this is actually the only interesting document. Everything else, I think, that we have on the list is just changing the status, right? So the bad ones downgrade, the good ones upgrade, right? But RFC 1112 is two things in one. On once, it is the actual specification of the ASM service model, for which we actually never built an IPv6 document. And of course, as we said, we don't want to deprecate the whole ASM service model, right? Even if the last step would be at some point in time, say, intradomain PIM sparse mode is not good, but intradomain BIDR PIM is, I think, always going to be excellent for, the applications it's built for, right? So, this is the biggest challenge here. My proposal would really be to ref this and basically come up, just strip out all the IGMP1 stuff, add IPv4, IPv6 in the rest, and that's going to be the new normative full internet standard for the ASM service model, right? That would be my proposal. Hopefully that's something feasible, because this is something like the holy grail of multicast, right? So upgrading RFC sub would try that we don't touch any of the actual content there, just, v4, v6, and get rid of all the IGMP v1 stuff. So then IGMP v2, right, downgrade historic. I don't really know the process. I think the historic process, hopefully there's going to be an AD in the PIM working group, and we can discuss that. Next slide. IGMP v3 needs to be upgraded, I think, to full standard. MLDV1 downgrade. Oh, there is a typo again. Sorry, this was all done quickly. MLDV2, of course, upgrade to full standard.
Oh.
Same argument as IGMP v3. Yeah, that's v2. Yeah.
But you're talking for both standard for one as well?
No.
We'll keep-
I'm just showing the current
Current status.
So this is the current. This is just the current. Yeah.
So upgrade, downgrade, upgrade.
Yeah. So I mean, the upgrade and downgrade for all these documents is pretty obvious, right? So
Yeah.
the old ones downgrade, the better ones upgrade. So 4604, that's SSM. That's the service model for V4 and V6 upgrade. Then we've got 3590. We'll have to check if that is actually, well adopted. So that seems to have been an addendum to IGMP v3 or MLD v2, I think. So we'll need to check that in more detail if that should become part of, the catechism in full standard. Then we've got the most interesting one, just, from the status, and that's the lightweight IGMP v3 MLD v2, which is kind of removing the nasty bits from IGMP v3 and MLD v2, which is the exclude sources list, which we never really used. So I have no experience about deployment stuff, but I would fear that that's still far away from really being full standard, right? That should probably stay proposed, and we may want to continue to suggest to people, to use it or not. At least it's part of the investigation group.
Yeah, Stig here. So so the interesting thing is when you want to make something an internet standard, you actually look at the spec and you decide which parts have like wide implementation and interoperability and all of that. And you actually take stuff out of the spec that that is not mature enough. In general, like we did that with PIM, we actually took some stuff out of PIM, like this border.
So you're saying we need to ref the document actually when we want to upgrade to full?
Well, I think what you're getting at is 3590 may evolve to look like 5790 when it goes to
Yeah,
standard.
so the thing is you have to go through like an implementation report and various things, deployment status. And it could be that we actually end up ripping that nasty stuff out of it. But there are some deployments, so maybe we will find that there is insufficient deployment. I don't know yet.
Well, I have no strong opinions, right? I'm happy if we don't have to go through the trouble of doing this stuff. Just if people stand up and feel strongly that this stuff has enough stuff, then I would obviously agree that we, do the job on that as well. I'm more interested in what you were saying with respect to what's the process. I was hoping, looking at older documents that seem to have been updated from proposed to full standard after a while, but now you're saying we may need to ref the documents and throw stuff away. So that's a discussion for PIM.
Yeah,
right?
basically look at the errata, see if there's issues to be fixed. Probably do an implementation report, maybe a separate RFC, like we did when we wrote sparse mode.
Right.
There is one RFC that is like an implementation report, and then after that we did like we took some stuff out of 4601 to make the
but that was a young junkyard. That was a 20-year junkyard, right? I feel a lot better about IGMP and MLD for that matter.
Yeah, so that makes the job easier. That's good.
Jeffrey from Juniper. This is related to Stig's comments, or related to the excluding sources. If we upgrade the original IGMP v3 and MLD v2 to full standard, then we need to decide if we want to remove the excluding sources function. And I was actually not aware of a 5790. If that lightweight IGMP v3 and MLD v2 is without the excluding sources, then we might as well just consider upgrading that 5790 to full standard.
And that would be an interesting question, right? If I just take IGMP v3 MLD v2 and basically try to change the text to say that, the exclude list must be empty, right? What difference would that be over 5790? Because 5790 rewrote everything, right? And so that's going to be a hard comparison. Maybe that's one of the tough jobs to do, because I would agree that if we need to ref anyhow and eliminate stuff that hasn't been used, it would be exactly that, exclude list having anything more than an empty list, right? So if that's the thing we could do to basically say, oh, we don't need 5790, we're just removing the exclude list, but there may be other protocol simplifications that 5790. So we'll need to check the authors list and figure out if any one of them is willing to help with the effort. Because, when this stuff happened, I was on the position of, having worked in a vendor that had spent a humongous amount of time to get the full versions of the protocols implemented. So there was little interest from our side to basically fix this. So now basically with a lot of time gone and we're trying to do the best for the IETF, let's see how we can deal with that. I'm just saying how it was.
No, you've revealed way more than you should have, but that's okay.
No, that's,
For what it's worth, at Juniper, we did the same thing. We started with a lightweight version of it before it was a lightweight version of it, and we just did include mode. And then later, we spent an enormous amount of effort doing the whole thing.
Yeah.
And only to not
Yeah, another question is about V1.
Now we care.
If we upgrade the V3 to full standard, do we have to downgrade the V1 to historic? Can we just leave it alone?
Why not downgrade V1 and V2 to historical?
I think Torres had a concern that if we downgrade to historical, then we lose the definition for the ASM
yeah, but
service.
remember, RFC 1112 doesn't even talk about IPv6. We have no normative document for the ASM service model in V6. So I think it would be definitely good to ref, split 1112, or just extract from 1112 the service model, which is the 50%, then comes the IGMP V1 spec. So we'll just take the first part, add V6 to it, something like that.
Well, so even if we didn't do any of the things at all, what's
Well, we
wrong?
just don't have a standard, a full standard definition of the ASM service model for V6. So if you want to do ASM, do V4, yeah, sure. I mean, some people might like that, but again, if I want to defend, the poor enterprises that can perfectly well do IPv6 BIDR PIM ASM, what's their reference?
Or maybe there's no one doing V6 multicast in the enterprise.
No, I don't think that's true. I think, the enterprises, as much as anybody else, are moving to V6 on the timeline that they can afford, right, in terms of if the vendor
I'm running
completely supports.
multicast.
Just take just a quick comment to Jeffrey. So we don't have to touch anything else in order to move that to full standard or internet standard. It's up to us whether we want to deprecate or whatever version 1. That's a different discussion.
Is what, sorry?
Whether we want to touch version 1, like deprecate it or whatever, that's a separate discussion. There's nothing automatic. We can make the new one internet standard without touching it. If you want to.
Mankamna, Cisco Systems. I just wanted to add one more document to your list, which is IGMP snooping. I think even that RFC is still informational, so maybe it will be good to make it as a standard.
So that the information on that one wasn't because it's not widely deployed or so, but because it's doing things implicitly. It's not changing anything on the wire. And there are basically these IETF policies that are saying, show me differences on the wire, then we can make it standard. Now, we're actually having the same discussion with the explicit tracking, where the changing on the wire is basically that traffic flows faster or, stops faster. And IGMP snooping obviously does the same thing, but, IGMP snooping has this smell of a layer 2 solution. That is, so that's a totally different discussion. We can have that again with the area director and see if something has evolved, but the information was because of that.
Sure.
Any other questions? It's good discussion. Thanks, Torles.
Yeah, and
Adjacent work?
You'll be presenting.
Yeah, we'll repeat this because it was so cool in an hour.
Very good. All right, cool.
Who's got the blues? Blue sheets. Everyone sign the blue sheet?
Sure.
Anyone not sign the blue sheet?
Sign them. Yeah, so PIM will be back in this room and it starts in 20 minutes. So if you'd like, you can stay here. No one will be kicking you out. But come on back in 20 minutes for PIM. Other than that, Mboned is adjourned. We'll see you in Bangkok.
So PIM starts in 12 minutes.